All right, so test-driven development with React. React is a front-end framework that hopefully you guys would know if you're coming to this video and you're just a beginner with any sort of programming. You don't know any coding. You're going to probably have a difficult time watching this. You might pick up something, you might understand some of the concepts that we go through, but honestly, unless you know React and unless you know JavaScript with React, and you don't have to know any of the unit testing or anything like that. You don't need to know Jest. You don't need to know Enzyme. I'm going to go through that. But if you don't have any coding experience and you're coming to this as trying to become a beginner, this is probably not going to be a very helpful video to you. Okay? This is really about a practice that we should be doing as software developers to be professionals, right? To do our job to the best of our abilities. So, 100% software engineering, love it. Thank you, Rolando. There's a few things that I want you to, we're going to go over about TDD and some practices here. So TDD is a practice. It is something that you do. It is something that you implement in the way that you build your software, right? It's some sort of practice. It's a thing that you do. So the first one, so this is TDD. The first thing that you do is you write a failing test. So this is totally outlandish, right? This first idea, you first write a test that fails. What are you talking about? So the most common way that we do development, right, especially when we're starting out, which totally makes sense, especially if you're starting out, is to just try to make the thing work, right? I've got this idea, I want to write the code to make it happen. So this kind of TDD flips that on its head, because what you're typically doing in those cases when you do normal development, I guess I shouldn't call it normal development, but when you kind of first learn about programming, you'll do this kind of coding just to make things work and make things happen. And then afterwards, you'll add tests, right? So afterwards, you might add tests, if you even know what tests are, right? Some of you may not even know how a unit test works. But essentially, you add a test afterwards, right? That's kind of the more common practice. You build whatever it is, and then you write some automated tests in order to make sure that it does the way that you want it to. TDD flips that so that you are writing your unit tests or your end-to-end tests or your integration tests before you write the actual implementation code. Okay, so that's how TDD works. You kind of flip that around. So you start off with a failing test. So you don't write an implementation code. You don't write a class. You don't write, you don't write up a module. You don't write up any of that stuff. You don't write a function. You don't write any variables. None of that. You write a test first, and you intentionally write a test that fails. You want it to fail. The whole purpose is to make it fail, because the next step is to make the test pass. So you write a test that fails, then you write an implementation that causes that test to pass. So it reverses that, right? It kind of reverses the way that we typically do things. And by doing so, what you're actually doing is you are forcing yourself into thinking from the user perspective, right? If I'm going to consume a function, how do I want to consume it? If I'm going to try to implement this function or this class, what are some of the things that I have at my disposal to give it? And based upon that, you start to draw out the design. It's explained as kind of a whiteboard process. You're kind of whiteboarding through the testing how you think things should work before you actually implement it. So you kind of design the system incrementally, slowly, and through these little tiny increments, but you do it a little bit at a time. So you write a test that fails, then you write the implementation code to make that test pass, and then the third phase of TDD is refactoring, where you go in and you say, okay, I want to clean up some duplicate code, so there's the dry principle, get rid of dry, or you don't want to have, don't repeat yourself. You try to look at ways to adhere to the solid principles, if you're into the solid principles, which of course I'm huge into the solid principles. when it comes to functional programming, you can't really do the Liskov substitution principle or interface separation principle, but that's okay. Still do single responsibility, open, closed, and dependency inversion. So you've got solid principles, you got dry, so you've got some refactoring that you do in order to try to make whatever it is that you wrote, whatever the quick and dirty was during the green phase, you now can reflect upon it to make it better. And one of the key things that I think most people don't do during the refactor phase is name things. This is one of the biggest points for me is you write a test, I don't even necessarily know what the name of the test is. I'm just going to write it because it's a whiteboard. I don't necessarily have to have a name. Then I make the code pass, right? I make the test pass. Then in the refactor phase, I can actually start to think, okay, how can I improve this function? Well, one of the first things I can do to improve a function is name it properly. Or if the way I want to name a test is to give it a proper description. So moving on, that's basically the cycle of TDD. You probably have heard of this before. Red, green, refactor, write a test, write the implementation code to make the test pass, and then refactor the code to make a better implementation. There are also 3 laws, okay? The 3 laws of TDD. I don't know if you guys can see this, but I'll read them out to you. And these were created by Uncle Bob Martin. First, you must write a failing test before you write any production code. So before you can write production code, you must write a test. Okay, so that's the red phase, right? Second, you must not write more of a test than is sufficient to fail, or it fails to compile. So by the way, a test that doesn't compile is a failing test, right? So you cannot write any more of the test than is sufficient to fail. Okay? That's a very little tiny increments that we're talking about. Very, very small. Just enough for that test to fail. Oh, and by the way, not compiling is a failure, right? Third one is probably even more, seems more outlandish. You must not write more production code than is sufficient to make the currently failing test pass. Okay, so this is just kind of, for the red phase and the green phase, this is the 3 laws that you're doing. You have to write a test first. You only write enough of a test for the test to fail. And then the third step is, or the third law, you can only write enough implementation code to make that test pass, but only as little as you possibly can. Okay, that is a cycle that you get locked into and you continuously repeat over and over and over again. Write a little test, write a little production code, fix it up a little bit. Write a little test, write a little code, fix it up a little bit. Write a little test, write a little code, fix it up. Like you just keep doing this cycle over and over and over again. Now the third one is kind of a cool one. It's called, they call it Enzymes or zombies, which I know I'm kind of blocking part of this. I can't really get out of the way. I should just, can I drop my camera? I'll just hide my camera. There we go. There we go. Okay, so the third one is called zombies, which is kind of a way of thinking about what the next test is that you're going to write. Okay, 0, you need to write for the test case of 0 things being passed to your function or 0 things being returned. Then you start thinking about 1 thing being returned or 1 thing being passed as a parameter. And then finally you get to the many. Okay? So you're kind of using this process of Enzymes. Null, think about the null cases, think about the 0 cases, think about the 1 cases, think about the many cases. And then the boundaries, interfaces, and exceptions are where you start to, you got to obviously think about boundary behaviors, boundaries of those behaviors. So that's kind of where the NZOM comes from, is that you're kind of stretching out the boundaries of the code. Okay. Then you're defining interfaces. If you're working with some sort of object-oriented programming, you're going to have interfaces. But you can also think of these interfaces as how do you want to, name these things? How do you want to accept the parameters? Those sorts of things. And then the exceptions. How do you want to throw exceptions? How do you want to handle exceptions? So that's the 3 practices of TDD that you should know about. Okay. Write a failing test, make it pass, and then refactor. Then there's the 3 laws. So you have to write a failing test before you write any production code. You must not write more of a test than is sufficient to fail. And by the way, failing to compile is a failure. And then 3, you must not write more production code than is sufficient to make the currently failing test pass. And then finally, when you're thinking about which test to write next, you're typically going to be thinking in terms of N-zombies. So what's the null case, what's the 0 case, what's the 1 case, what's the many case, and how are we stretching the boundaries, how are we defining the interfaces, and how are we handling exceptions, okay? And you're always trying to do simple solutions with simple scenarios. So, okay, all of that, my goodness. Oh, where's my camera? Where'd my camera go? There we go. Yay, I'm back. Steve's back. Okay. Sorry, I am technically still, I shouldn't say on the clock. I'm not really on the clock because it doesn't work that way. But I do have to keep an eye on business. And this is a live stream that I decided to go on during the day. So, okay. So hopefully everybody's got the 3 practices down, right? Red, green, refactor, 3 laws, and zombies. We will be referring to these occasionally throughout this video. So let me just get my screen set up so that I can go through the lesson. So the first thing is we're going to want to, we're going to start off with a blank React application. So we're going to go ahead and do, let's change into my projects folder. This is where I like to hold all of my projects. This is, so for those of you who are not familiar with what we're looking at, this is a bash command line. This is a special one installed for Windows. It comes with Git, so it's called Git Bash, and I have it set up with my Windows terminal. So this little special terminal that they have that you can do drop downs, you can do all sorts of different ones. I have Ubuntu installed on here, so I could do Ubuntu instead for my bash command line. But I'm using the Git Bash. I love the interface. I think it's great. So that's the one I went with. Okay, so these are going to be bash commands that I'm going to be typing in occasionally. So if you're used to Windows development, some of the commands might they're very, very similar, but some of them might look a little different. Most of everything I type here is going to be the same though. So we do need to create a new project. So we're going to do, let's see, we need to do, npx create React app. And we're going to name this thing. So we're just going to do a very simple example. It's going to be called a person app. So we're going to say person app. And that's going to go through, and this is going to take forever to install. So I probably could have done this while I was going through all the different practices. But while this is going on, so we've got, let me talk a little bit about testing in general as far as so some of you may have seen the pyramid, the testing pyramid. Heck, maybe I can pull up a graphic of it. Let me find it here. Testing pyramid. Oops, pyramid. See if I can find it here. That's not it. Yeah, okay. So here's just an example of the testing pyramid. You need to understand where you're what you are testing and how it fits into this pyramid, because the UI testing is going to be the slower test. These are what we often call end-to-end tests, where you are testing kind of the complete system from top to bottom. So if a user clicks on this button, it's going to go, talk to the API, and the API is going to go hit the database. The database is going to return some data that gets formatted by some sort of like entity framework or some sort of ORM. Then that gets returned back as part of the RESTful API, which translates over to JSON. The React application is going to, fetch that. It's going to take that JSON. You have to convert that into an actual JavaScript object. That has to then be, displayed or passed in through like Redux in order to, if you're doing global state management through Redux, then that's going to have to go through all of your reducers and actions and stuff, and then finally we get something that comes out of it, right? Like that's a lot to go through, so your testing there is going to be much slower. Where are we at on that? So you need to make sure that you understand what you're testing and how it's going to affect the speed in which you're testing. The service tests, which we typically call integration tests, are where you're kind of looking at the different layers and making sure that they're interacting with each other properly. And then the third one is unit tests, where you're really trying to encapsulate just this one little tiny piece and making sure that the completeness of that little tiny piece is exactly how it's supposed to be, right? So you're testing inputs and outputs. So basically, unit tests are kind of where traditionally you do TDD from. Because you're building things small and incrementally, it makes sense to do so from the unit test foundation. And you can kind of learn and explore as things start to expand beyond that one little test that you wrote, or those little test suites that you're writing. You kind of learn what are some of the other actors that I need in this system in order to make the whole thing start to work, okay? So you start kind of doing these unit tests, but then you start adding these integration tests to check those integrations of those different units. And then finally, you kind of build these end-to-end tests. That's the more traditional way. They call it the Chicago style, or classical. It depends on, or traditional. Kind of depends on who you ask, but Chicago style, which doesn't really make much sense. I prefer, personally, the term inside out. Inside out testing. You start with the smallest inside thing at the lowest level, and then you kind of build up from there. You go inside out, right? The other philosophy is outside in, which is kind of the reverse of that, where you start with the end-to-end tests, and you have this essentially a spec that you need the system to eventually complete. So you start with that, and as you're saying, okay, so this is going to do this, you start to determine what all the actors are in order to make that happen. But that one test is essentially kind of guiding you along the whole trail to the end and determining what all those actors are. And you kind of build the unit tests along as you go. You kind of start out with this end test, and then as you start to build these things, you add unit tests along the way to help build those things. And that's kind of a different philosophy, but there's a lot of similarities there. It's just mostly a matter of whether or not you have an end-to-end test in there. So we are going to, hopefully, everything is installed. So here we have npm start, npm run build, npm test, npm run eject. And in order for us to get started, we need to do this change into the directory of person app. So let's go ahead and do that. We're going to change into person app. Now, what I'm going to do is I'm not going to start the application. I'm going to do npm test, and this is going to run all of the tests that are in the application. And if we take a look, we see, oh, no tests were found. Interesting. Since the last, no tests found related to files changed since last commit. Okay. So this is kind of cool because Jest has a watcher. So we're running tests in Jest right now. It found no tests. I should say it found no new tests. It's got a watcher, so it watches to see if any files will change. And if files change, it will automatically rerun the tests once it sees the change. And it'll do this if you change a test or if you change the implementation code. It knows, it's watching all these files, and as soon as anything changes, it'll run those tests again. If you want to manually trigger it, you can just type A from here and it'll run all the tests again. Okay, so we're going to see this screen up pretty regularly, and there is a test in there. It's one passed, and I will show you that. It's in the apptest.js file. So let's go ahead and I'm going to cancel out of this. I'm going to type in code period, and we're going to open up our application in Visual Studio Code. And it said that it found it in apptest.js, and if we take a look in there, there is a test that is passing, okay? So there's a way of writing tests that we're going to go through. This is the first one. This is the one that comes out of the box. You can use the word test in order to define a test. You can also use the word it, which is kind of the more popular way to do it, because as you'll see, the syntax of using it in the way that we're going to be writing out our test suite is going to make a lot more sense. And it's going to read properly. It's going to kind of read more like regular English when we do it. But it says basically it renders learn React link. So we're checking to see if it renders the learn React link. We define a constant, which is to go get the app component. Then we link element get by text. So we use the get by text to find this bit of text. And then we expect, which is our assertion here, that the link element is going to be in the document. Okay, it's got to be somewhere in there. So this is all good and fine, but there's a couple things I need to do here. The first one is I want to add I need to add a JS config file to give us a little bit of some IntelliSense. And I'm just going to copy and paste this because I don't want to have to type it all out for you guys. But essentially, it's going to be this. It's type acquisition. You need to include Jest. Okay, and this is pretty easy to find out there. If you're looking for it, just type in IntelliSense with Jest, and you'll find out how to build this JS config file. But now that that's in there, that's going to give me some IntelliSense on Jest. The other thing that we need to do is we need to install Enzyme. And Enzyme is a special library for wrapping React components, and gives us a little bit of a different interface in order to work with those components. Because right now we're just using Jest, which doesn't... Jest is a more generic testing runner and framework, whereas Enzyme is kind of a special library specifically built for working with React applications. So I'm just going to open up the terminal down here so that we don't have to, flip back and forth between screens. And I'm just going to type in NPM ID, and this big capital D is basically short for save dev. Enzyme is the package we want to install. So this is going to install the Enzyme library for us, and I can just show you guys here. If we take a look at the package.json file, in the development, there it is, dev dependencies, you'll see there is now Enzyme, and that's what we're looking for. We need Enzyme to be in there. So we'll see Enzyme, we'll see, by the way, Jest. The dependencies for Jest come with React. With the create React app, so that's already installed. But in order to get Enzyme, we have to do that command, okay, to add it in there. All right, so now that we have Enzyme, cool. I'm going to get rid of this initial test. I don't want that anymore. I'm going to write my own test. Now, I'm in the red phase. I need to create a test that fails. That's the first thing. Okay, I need to create a test that fails. So what I'm going to do is I'm going to actually let me. Do I want to? Let me talk real quickly about the DOM. Well, not really DOM, but the React component tree. So we've got this index.js file, which is going to be loaded into the application first, right on the page. Then we are including it in our React DOM render. So this render function is going to actually render these components to the page. Okay, so render, you're passing in these things, and it looks a lot like HTML, but it's actually a syntax called JSX. And we are putting our app component inside of this thing called strict mode, which I'm not going to get into that at all. But essentially, you're putting the app component, you're displaying the app component on the page. Okay, that's what's essentially going on. You know what? Let's take a quick look at this. You guys may have not seen what a React application looks like out of the box when you just do the initial install. So let me get this thing kicked off. It just looks like that. That's what we have to start with. Okay, very simple. But this is that app component. Okay, the app component is being rendered on the screen right now. And so we've got it here. Index.js has this React DOM render, which is including the app component. Then the app component is going to be this little doozy right here. This is a functional component out of the box. We'll talk about that a little bit later. But essentially, there is what looks like HTML, but it's actually JSX, and it gets converted into JavaScript, into React components. So yeah, but it's meant to look a lot like HTML. So it's going to look like we're dealing with HTML, but we're really not. Okay, oops, wrong key. There we go. So that's what we're seeing there. I'm going to actually get rid of everything that we have so far as the header and the link and all of that. I just want to start out with a div labeled app. All right, my viewers fluctuate. I'm not sure if that's a good thing. Okay, so what we're going to do here is we need to write that test first, right? So we need to write our first test. You start off by creating a suite. Okay, you need to create a suite around a particular system under test, and you start by creating a suite. You create a suite by using the word describe. Okay, now when you're doing describe, you need to pass it in a string and a function, and the string is going to be a label for what it is that the suite is covering. So typically this is just going to be the system under test itself. So I just like to say app. So we're going to describe app. And then we're going to say in a function, which I'm using the arrow syntax function, we're going to say, okay, we need to describe a functionality, a behavior of the app component. And so we're going to use the it function, which these are global functions provided by Jest. So Jest has these components, has these global functions that we can call upon, describe and it, along with some other ones, like before all and before each, which we might talk about a little later too. But essentially, we now need to do very similar to how we did describe, where we said a label for this thing and then a function that we're passing in. Once again, with it, we give it a label and then we provide a function. So this is now, describe is our test suite. It is our first test. Okay, and right now it doesn't look like it's doing much, but I can actually run NPM Test from here and we should just basically have a passing test, right? We sure do. All our tests pass because we haven't said anything. We haven't set up any sort of assertion to fail at this point, okay? So we need to actually write our test to actually test a behavior. So what we're going to do is we're going to say, now I like to wait to label my tests. I like to make that part of the refactor phase. But what we can do is we can define a constant called app wrapper that is going to contain the result of going and getting the app component. Okay, so we want to go get this app component so that we can inspect it. It's sort of like when you're like, create an instance of the class for me. Go create an instance of the component for me so I can inspect it. Okay, so to do that, we're going to say shallow. We can talk about what shallow is in just a moment, but I essentially now want to say the app component is what I want to wrap. So I'm creating a wrapper around the app component. Okay. So the app component is what I want to go get. I'm creating kind of this instance of the app that allows me to inspect the app component. We call shallow shallow is a way of basically forcing it to not load the entire child tree of the app component. We're only loading app. That's the only component that gets loaded. Because when you're dealing with React, you have typically some sort of tree-like structure of here's our app component, and then all the other little components that could be displayed on our application kind of branch out from there. Okay, and I'm saying I don't want to get the whole branch, all those branches and everything. All I really care about is just this one app component, and that's what we're going to inspect. Okay, so we're going to go shallow on app. So this means don't render any children of the app component. Only render the app component itself, and we're going to inspect it. That's essentially what shallow does. Now, there's going to be some problems, though, because we don't have something called an adapter installed. Shallow is not defined. I haven't brought in shallow, so shallow is a function I need to bring in from Enzyme. So I'm just going to do an import from Enzyme of that shallow function. We can get rid of render because we're not using the testing library that comes with React. We're going to use Enzyme instead. Okay, so that's in place. Now that we've changed our code, notice that the testing framework still continues to run. Okay, now we have a new error. Import adapter from Enzyme adapter React 15. So I'm actually going to run the Enzyme adapter React 16 because I'm running React 16. So that's what I'm going to add. To do that, let me pop out of this, and we are going to, let's run NPM, oops, I'm in the wrong screen. There we go. NPM I, which is short for install. Once again, we're going to do the capital D to put this in our dev dependencies. And then we want to do, let's see, what was it called? It was where'd you go? I know I had it in here. There it is. Enzyme, it was that command. We saw the library it was asking for, right? Enzyme adapter React. But this time, instead of 15, I'm going to do 16. And I'll tell you why. It's because if we look at the package.json file, we'll see that React is version 16. Okay, React and React DOM are version 16. And so the adapter we want, I think, should be for version 16. I think 15 will work, but I don't want to try. I just would rather go with the correct version. So, okay, now that we've got that in place, the next thing that we need to do is actually set up our configuration of the adapter. Okay, so we installed the package. Now we have to go create an instance of an adapter for Enzyme to use to wrap that app component. So what we're going to do is, there's already a file here. Here we go. Set up tests. This is where where Jest is going to kind of set up the tests, the test runner essentially, and we want to add an adapter for the test runner. So we're going to say configure, and the function we want to call, or we want to pass, the object we want to pass into configure is a object that has a property called adapter, and the adapter we want to set up is a new adapter. Now, I think we have to import, yeah, we have to import adapter from Enzyme as well, except it's going to be that import adapter. So this adapter object that I'm bringing in is going to come from that Enzyme adapter React 16. So this is the adapter for React 16 that we're creating an instance of, okay? And then we're doing the configure function because that's what Enzyme uses in order to figure out how to connect itself to Jest, okay? So Jest is the test runner. Jest needs to know how to talk to this React application. It's already got some typical stuff that it usually works with, but we saw that I just deleted that. I deleted the React testing library. I shouldn't say I deleted it. I just didn't import it, right? And instead we're using Enzyme to do this. And so I'm going to bring in this adapter. All right. Wow, 2 whole views. I'm taking a long time to go through all this stuff. So that's kind of the thing about me. I like to explain everything as I go along, and it takes me a little bit longer to go through. And I think some people kind of lose interest because I go so in depth. But okay, so now that I have that in place, what happens when we do NPM test? Hooray, we are passing. Okay, all right, so now we wrote just enough of a test to fail. Then we implemented the code, just enough of the code, in order to make it pass. We actually completed our first red-green cycle, and there's really nothing to refactor here. We can evaluate it. Oh, actually, there is something to refactor. There's almost always something for me to refactor. I keep forgetting to do this, though. It does not have a description. So what I'm going to set this to is renders without crashing. And whenever you make a change, you should always rerun your tests, which automatically does, which is really handy, and we still see that it passes. So even the thing that we're starting to get from doing this practice of test, make it pass, refactor, is that my application is in a working state, right? And if I wasn't sitting here describing and explaining all of this to you, that whole process would probably take maybe 30 seconds, right? To go through the red-green refactor and everything would take 30 seconds or less. So that's the kind of cycle that we're trying to engage in over and over and over again. Okay, so let's move on to the next red phase. Let's actually figure out, so what I would like this application to do, and I haven't talked about the design of this, but the initial intention is I'd like to have a list of people that I can edit. So I'm just going to have a list of people on my page, list of names, with an edit button that I can click on that will take me to a page that I can edit that person. That's all. That's the only use case, a very simple thing, but I'm trying to kind of drive this whole thing out for you guys and explain it along the way. So what I'm going to do, you know what? I don't like how this is taking up half the window, so maybe I will kind of switch over to, let's do this. I'll keep this window up as my test runner so that we can, and I'll flip back and forth to it. I typically work with a larger window so I can have the tests running on the bottom. But for this demonstration, in order to make everything clear, I've expanded or made the screen a little bit larger. But I need that screen real estate to work with for my coding. So we'll do that. So now I need to write my next test. We've completed one cycle. Now we're back in the red phase. We need to create a test. So we're going to do it. Again, I don't know what exactly it's going to do. I don't have a good name for this yet, okay, of how I don't like to give it a name until I actually have the code written, because then once I have the code written, I know what it's doing and I can properly label it. Like, I don't know, it seems like a foolish thing to a lot of people, and when I talk to people about this all the time, they're like, what are you doing? Why? You should already know what it is you're testing. Why don't you give it a name? I'm like, well, because that may not actually be the test that I write. I want to write a test first, and then now that I know what the test is, I'm going to have a way to properly label it. So anyway, I'm going to write my test now, even though I don't have a name for it. But what I do know I need to do is, I said I want this application to display a list of names. So obviously, this app component is going to need to display some sort of component that gives me that list of names. So let's do that. Let's say I'm going to need to take this const app wrapper. I'm just going to copy this. So there's my app wrapper. Then on my app wrapper, I'm going to find. There's a special function called find that comes with our enzyme, right? That allows us to pass in a component that we want to find on the app component. So we're saying, I'm wrapping up the app component, and then I want to find on that app component another component. And I can pass in what that component is. The component that I would like to see, now we can start to make some design decisions. What should I name this component that it should find on the app component? I'm going to say person list. Okay, now obviously, once again, if we look at our tests, this is going to fail. Of course it's going to fail because we don't have a person list. Remember, part of the second law of TDD is that you write only enough of a test as to fail. And right now we have a failing test because, of course, there is no such thing as person list. So how do we then go and make this pass? Well, we go create a person list. So great. Okay, let's go create a person list. Person list.js. And I'm going to do something really, what some people think going to be real dumb, but the third law of TDD is write only enough of an implementation as to pass the test. So I'm going to do export default. That's it. That's all I'm going to write right there. And watch. Oh, I got to import it. Still doesn't know what person list is. But, so I have to go back here and I have to say, so my test, I can close that down. My test needs to know what person list is. So let me add that. Import person list from person list. Okay, it's still not going to pass though, because this is looking for person list in the app. So I need to go into the app component and actually just add, okay, you're going to call person list. Great. Right? Person list is all in there. Now let's take a look at our test. I think I still need to import on my app component. Yeah, it doesn't know what person list is, so we're still having a failure. So I'm going to get rid of this logo because we don't need that. I also don't need the app CSS. We can get rid of that. But I do need to import the person list from person list. Oops. Okay, so now that that's in place, aha, we have tests that pass. Woohoo! We just finished up the green phase, right? So we wrote we wrote our second test that failed, and now it's passing. Now, you can still think of this as the refactor phase or as another. I think that this is another red-green refactor phase, but we still need to finish up this test. The test is not done yet because I don't have an assertion. I need to create an assertion. So what I'm going to do is, let's do expect person list. So what find is going to do is go find that person list, but we can get it as kind of an array. So all of the instances where this person list is found can be thrown into an array. So I'm going to define this as my person list. And then we can inspect the person list to see, okay, I should only have one of these, right? I should, as something I can test that I can assert, I should be able to say, I should only see one of these person list components. So we're going to say expect person list to have length of 1, which basically means check that the person list, which should be an array, make sure that the length of the array is 1. There should only be one element inside of this person list array. And that should still pass. Yep. And I'll just double check again. We are still passing. Yep. Okay, so that is now a completed test with an assertion. And now we can move on once again into our next red phase. So actually, refactor. Got a refactor. Yes. Must refactor. What do we want to call this? Renders a person list. Good enough. Okay. So now we have that. Next up. Let's do, what's the person list going to render? What is the person? Okay, so how is the list going to get a set of names? Okay, because we said that we want this list to show some names. We need to define some names somewhere. Okay, where do we want to define those names? Well, we could go all the way into a Redux solution, but that's a little bit beyond this, and that's not a very simple implementation. The thing that makes the most sense, at least at this stage of the development cycle, of the development process, is to just create some sort of object at the root component. Just create some sort of object that contains all of the names, right? Or an array of names. So again, I know that that's what I want to do, but do I just go right into the app component and start doing it? No, I need to write a test first. That's the whole point of TDD. Write a test first. So what I'm going to do is I'm going to write my first test for this particular, I'm going to write a test. Again, I don't know exactly how I want to label this. We'll do that in the refactor phase. Okay, so what should the app component be able to do? We know that we want it to contain some sort of object for person list, but that means in order for that to happen, the app component has to have something called a state property. So let's just double check to make sure that the app component has state. We can do that by doing app wrapper state. And let's assign the state to some sort of variable here. We'll call const app state. Okay, so we're defining app state, and we're setting it to the state on there. Okay, let's take a look at our test and see, uh-oh, we have a failing test. Shallow wrapper state can only be called on class components. So state does not exist on functions, on functional components, which if we take a look at our app.js file, it is a functional component. It is not a class component. So I'm going to fix this by converting this to a class called app, which extends component, which I'm going to import up above here from React. And then I need to change this return to render. All right, now let's take a look at our tests. And we pass. Okay, good. So now that I have that in place, I need to make sure that that the state, so now that I know that I have state, I need to determine what, so remember going back to zombies, going back to this thing here, zombies, 0, 1, many, but there is an N also. There's N zombies, which means new or null, okay? So I want to have N zombies, my first test that I want to write for this to check the state of the app is, what if I have no people? What if my state is null? Okay, that's kind of the first case scenario that I want to check for. So that's what I'm going to write for this assertion. I'm going to say expect that the app state should not be null because I don't want it to be null. That's the case, right? I'm looking, so what is the, when I'm looking at N zombies, I'm looking at N is saying null. What is the use case around null? Null is something I don't want in my state. That's what I should be testing for. I want to test what happens if it's null. Null should not be okay. That it should fail that. I want there to be state. Otherwise, we've got a problem. Okay, so by doing that now, we're back to a failing test. Okay, so in order to make this pass, what do I need to do? Well, I need to add a state. I mean, look at that. See, expected received to be null, and it received null, or to not be null, and it received null. So something's clearly wrong here. How do I fix that? Well, let's go back into our app.js state property, set it to an empty object. Now let's take a look at our test, and we're passing. Because now it's not null anymore. Okay, so the next case is going to be, what do we want for, let's see. Do we have any refactoring? Because now we have a passing test. Let's go to the refactor. Yep. So what do I want to call this? Let's say, what did I give this in my notes? I said, oh yeah, just has state. There we go. Okay. Does that refactor cause a problem? No, it's still passing. Okay, good deal. Okay, next up, we need another test. We're back to the red phase. I don't know what it's going to be called. Okay. So the next thing is we have nothing useful for the people list. So let's add some people to the property state, shall we? Let's do that. To do that, let's do... So we need to, on the state, we need to say, okay, how are we going to store people? We know that we want a people list. This people list is going to be on the state of the app component. So we need to check to make sure that that people property exists on state. Okay, so we're going to do, once again, const app wrapper. And then we're going to say const app state. So we're going to take, actually this line, I should copy both of these lines, huh? And then we're going to expect that app state, we should on app state be able to find people, right? So I should just be able to find a people property on that app state. So my assertion here is going to be, hey, that people property should be defined. There should be a people property on here. So we're going to say to be defined. And of course, that is a failing test because people property does not exist on state yet, right? Received undefined. Okay. So since that's undefined, let's go back into our app. How do we fix this? What's our green phase? Well, we need to add a people property, which I'm going to initialize this as an empty array. And now we go back to our tests and we're passing green again. Okay. Now, we're going back into the refactor phase. And I think at this point, you guys have seen me do some redundant things, right? So we can start to evaluate some dry principles or just what are some ways that we can clean this up? And I think this is an obvious one. I have called this app component with a shallow wrapper in every single one of my tests. So there's got to be, this redundancy is something that I should probably try to eliminate. And what I can do is before all of my tests, I can say before all, I want to take and assign to this constant app wrapper. Oops. That wasn't what I meant to do. So before all of my tests run, do this. Set up the app wrapper. Now the problem is the scope of this is inside of the before all. I need to move this app wrapper to out here, and then I can assign it inside of the before all. Now that I've done that, or create app wrapper, either way. So before all of my tests run, I'm going to create this app wrapper thing. And now that I've got that app wrapper being created before I do any of my tests, I can essentially eliminate it from all of my tests, which makes this test completely useless. So I'm going to delete it. Okay, then I'm going to do this one, and this one, and this one. So I just refactored out a ton of code out of my tests. By the way, double check, am I still passing? Oh, no, I'm not because, oh, I set it as a const. That's right, you can't do it as a const here. You gotta do it as a let. Now my tests, are they passing after my refactor? No. What did I do wrong? What did I do wrong? Oh, I know what it is. There is no statement of what to do. That's right. There's no label for before all. There we go. Just habit. I'm so used to giving everything a label. But there we go. So now before all of our tests, so this refactor of moving app wrapper to this let and doing the assignment in this before all my tests continue to pass and all my code is still in a good working state. Now I can also go back and refactor this and say, so we're going to say has a people property on state. Okay, so there we go. There's my next, that was my next test. By the way, I just refactored. Every time you make any sort of code change, go back, take a look at your test. Yes, everything's passing. Okay, so now what's our next test? What's our next test? We need to, we need to make sure that the people, this people property is being passed to person list because the person list needs that list of people, right, in order to render whatever it's going to render. So we got to make sure that that passes. Now, again, I could just go right in here. It's very tempting. It's very, very tempting to just go right in here and add the assignment of people as a prop, right? It's very easy. I could just do that right now, no problem. But we're in test-driven development, which means I need to have a test around that first before I write the code. So I'm going to go into app test again, say it. I don't know what yet. I sort of do, but I don't know what to name it. Okay, what am I going to do? Well, I'm going to make sure that this person list thing that I can go and get, which we saw I can do this here to go get that person. I'll just copy that and paste it here. So I've got my person list. I need to make sure that on the person list, that property of people, the people thing, is being passed in as a prop to this person list component. So I can enforce that by doing an expect. Oh, by the way, let's just double check, make sure I wrote that line of code. Are we still green? Yes, we're still green. Okay. So I don't have a failing test just yet. I have to do my expect the person list. Okay, that person list dot props. So props is a function that I can go and inspect what's being passed to the person list as props. I'm going to get this list of what are the props, and on it there should be a people property on it, right? There should be a people prop. And not only that, but it should equal the same people that's on my state. So I should be able to look at the app wrapper and say, look at the state, and there should be people on it, right? So those two things should be the same. They should be equal. And now, when I look at it, of course, my tests are failing because it expected an empty array, but it received undefined. Okay, so now I have a failing test. What can I do in order to make it pass? Well, we go into the app component. Now notice I am not doing anything with person list. It is still just this empty function that gets returned. That's kind of the isolation that you're doing with that shallow wrapper of Enzyme, is you are not looking at what's happening with the child. You're only looking at what the app component itself is doing. Is it passing these people as a prop to that other component? Okay, we found out it's not. So we need to create that people prop, and we need to send it this dot state dot people. Okay, now if we take a look at our test, we're passing. Great. Is there anything to refactor? There almost always is something to refactor for me because I like to wait until the end to give this thing a label. So I'm going to say passes people property of state to people or person list as prop. Okay, now I've given an accurate description of what the test is actually testing. Pat Bernard says, see all your Axis videos. Big fan of yours since then. You definitely know how to pass on your knowledge. Thank you, Pat. I appreciate that. I'm surprised I've got 12 viewers for what I figured was going to be a pretty boring lecture here, but I'm glad you guys are with me, so thank you so much. Okay, so there's my refactor. Oh, by the way, since I refactored, what do? We always go check, make sure the tests still continue to pass after a refactor, which they do. Okay, good. So next step, we need to make sure that, okay, so maybe we pass people to the state. Okay, already done that. Next one is we want, so in order to create the person list, okay, so we have essentially done just about everything we can to this app component. Okay, we've created some state. We've added a property on it of people that's going to contain people values. We've made sure that there's this person list in there. We've made sure that the people are being passed to the person list, right? So we've got a whole bunch of tests around all of that functionality. The tests have driven it out. And again, one of the great things about this right now is we know that this application works. If I wanted to go run it right now, I could do, let's cancel this. I could go run my application. It should work because all the tests pass, right? Uh-oh. Means return statement is missing or to render nothing. Oh, it's because I still don't have, okay. Look at me being a liar. It's because I don't have it. It's not rendering anything right now, right? There's nothing to render because I made that component just a function. So it's complaining about the fact that I did this. It doesn't like that at all. It needs something to render. I'm calling this person list, but my tests pass because as far as app is concerned, that is done properly. But now I have to go inspect this person list, which is currently not really working. And I've got to make it work. So I love how it just called me a liar. If I had done something a little bit more simplistic, like if I did this, which is really what I should have done with this, like to do a proper starting implementation. I just wanted to show you initially how you could make a test pass by doing this simplest little thing, and now it just bit me. But I could just do this. That's also perfectly valid to do, and it should now compile and everything. And if we take a look at, let's bring this back over, localhost 3000. Now it's not going to complain anymore because now I gave it a valid thing to render. And in it, understand that person list is something that I don't have any tests around. So yeah, I need some tests around that. That's probably where we're going to head next. But you'll see, yeah, even though it's a blank screen, it's at least not failing. And if we take a look at the console, there's no errors. So this is doing just what it's supposed to do. And we have a working application. Okay. I'm going to revert this back, though, because I just kind of want to do that. We can close out of this. Kill that. I think that killed it, right? Yeah, okay. Come on, close. There we go. VS Code is slowing down on me. Oh, no. Okay, so now we need to start looking at this person list, which means right now we don't have any tests around person list, so let's go ahead and create that. So the convention is to add, there's actually different ways you can add tests to the application. You can create like a test folder and just stuff it all in there. I prefer putting the tests side by side with the implementation code. So wherever I have my person list is also where I have my person list test. So in here, what we want to do is we need to start describing this person list, right? So we need to do some imports. Let's import React from React. We need to import that shallow function again from Enzyme. And we need to import person list from this current directory. All right, now we can go ahead and describe. So we're creating our test suite. The thing that we are describing is the system under test, which is the person list. And we're going to give it an arrow syntax function here. And we're going to write our first test. It what? What should it do? All right. I could write my first test. Oh, that's terrible. There we go. So my first test could be, and probably should be, just making sure it renders, right? But I'm going to go one step a little bit ahead just to kind of save time. And I'm going to say const person list wrapper is set to shallow of that person list component. And what I want to do is so as part of my design of person list, I'm just going to make this a simple little unordered list. So I'm going to make sure that there's an unordered list component that gets rendered on this. So I'm going to say person list, expect person list person list wrapper. There we go. That's the one I want. I need to find. I could actually do this up here. So I'm going to do kind of how I did it in the first one. I'm going to say const people list ul. We'll say is from person list wrapper dot find. Oops, I got to assign this. Person list wrapper find. And I want to find a ul element. So this is another one of the ways that we can select an element on the shallow wrapper. So we saw, just to give you a comparison, when we did this app test, we wanted to find person list. We were passing in the actual class, or I should say the module, right? This object called person list, go find that person list thing. But you can also, as a selector, just say, hey, I want to go find an element by this name. Go find a tag called ul. And again, this is going to put in, this is going to be a array of sorts, right? It's going to be it's a collection. So on that people list, what I can say is, rather than person list wrapper, I'm going to say people list uls. There should only be one of those. So to have length of 1. Now, of course, this is going to fail as we take a look at our tests. And yep, there's our failure. Expected a length of 1, received 0. So we need to somehow make it so that my person list returns an unordered list. Let's go ahead and fix that right now. Wow, that was really hard, huh? There's my test failing for some reason. Oh, React is not defined. That's right. I need to, since this is JSX, I need to bring in the React library to make this work. Notice that the test suite is helping me identify all my errors, right? This is the great thing about test-driven development, is like every single thing that you do, you have a test that's telling you when you're doing it wrong, because you wrote a test first to tell you how to do it, right? So good. Okay, well, now we're passing. We can switch back over. Do we have any sort of refactoring? So one thing I could do, so that was the simplest thing. Some of you might be tempted to do kind of this return, like if I did it this way. Arrow syntax function is kind of one of those things that not everybody totally understands. I could have written it this way, and that would be perfectly acceptable. That's kind of the more long way, and notice my tests still pass. But whenever you're doing arrow syntax, you actually, if you're only doing one thing in that function, just one line of commands, you can just drop the return statement altogether and just do the thing, right? So that's what we're doing there. The only reason why you use curly braces is to define scope of multiple things to perform. That's the only reason why you use curly braces. And pretty much, I mean, it's not, I'm not going to say universally, but that's kind of what you do in a lot of lines. But yeah, we're still passing with my UL just being right here on the export default, so we're good to go. Next thing we want to do is we want to go back to the idea that, okay, what if there is 0, so null, 0, 1, right? Zombies. Null, 0, 1, many. Okay, so the first use case is going to be, I think just, I don't know how I feel about n. N only comes into play once in a while. I'm more of just straight zombies, like 0. But, so if we go, I'm going to close app test and app component because I'm not working on those right now. I like to kind of keep my desktop a little tidy so that I know what oh, look at that. I forgot to do that during my refactor phase. God, Steve, you got to stop doing that. Renders a UL element. Okay, good enough. And I refactored, so just double check, passes all the tests. Yes, of course it does, because all I did was add a label. Next up, it. Hope you guys are enjoying this stream. It's a little different for me. This is an actual, by the way, this is an actual lesson that I would give. Like, this is an actual, I'm kind of roughing out the edges here with you guys, but this is actually what I would be doing in my day-to-day job. So awesome stuff, right? You guys get kind of an insider glimpse into what it is that I do. Okay, so we've got it. Let's see. We're going to do a const. Okay. Let's talk a little bit about what we need this to do next. So we now have this unordered list. Now what we want to do is display for all those people, right? We had this people array being passed from the app component down to person list. What we want to do is we want to make it so that people, right, that those people are being displayed inside of the unordered list. And we do that by creating an LI element for every person. So to do that, let's start off with, and this is going back to zombies. What if I have 0 people? What if that people property has 0 people in it, which right now it does. So we can just go ahead and say, let's create a const person wrapper. Person, here, just copy this up here. Actually, we'll do both of these, I believe I need. No, actually, I don't. I don't need the UL. Because I can find the list item elements from the person list component itself. So I'm going to do this. You're welcome, Pat. Thank you for hopping on board here. Okay, so now what we're going to do is we need to say, okay, so I've got this person list. I need to look for all of the list item elements. So I'm going to say const people list items. And this is going to be on that person list wrapper. I'm going to find all the LI elements. So again, this is going to give me basically an array. It's going to give me a collection. It's not really an array. I don't think technically it's an array. Yeah, it's just a shallow wrapper HTML attributes. It's a collection. You wish you had a smart question to ask right now. Well, that's okay, Pat. I appreciate you following along. Like I said, this is what I do. Like, this is upskilling. This is, if you know how to do tests, if you know how to do React, if you know how to do software development in general, but you've never done test-driven development, that's what I'm trying to show you, right? This is a type of practice that you should be doing in your daily life in order to make your code better, right? We're making code better by doing testing first and making sure that all of these use cases are covering the performance of the application. So what do I want? Well, I want to make sure I expect that people list items. There should be 0 of them, right? There should be none. Because people should be empty. And just to be absolutely sure of that, let me do this. I know that person list from the app test, we were saying it should be handed a list of people, right? We were saying it's going to be getting this prop called people. We know that from the test, so I'm going to just doubly make sure with an empty array that I'm going to pass along okay. Now, failures. Yay, we have a failing test. Yay, we have a failing test. We have something to implement. Wait, what? Oh, darn, I got so excited. And the reason is because, obviously, right? If I don't have any people, how many list item elements is person list returning? 0. So it's going to pass the test. We did not write a sufficient test in order to cause a failure. However, does that mean that this test is not a good test? No, actually, it's quite a good test. We want to make sure that when there are 0 people being passed to this person list, we get no list items. So this is a perfectly valid test. So I'm going to say I'm going to leave it in place here. There's nothing wrong with it. Renders no li elements when no people exist. Okay, I refactored. Check out the tests. Yep, everything still passed. By the way, notice that we have 2 suites that passed. This is because it detected 2 describe functions. So each suite is called each describe is called a suite, and then inside of the suite we have all these tests. You'll notice I have 2 suites with a total of 6 tests between the 2 suites. So everything is passing. Okay, ran all test suites and everything passed. Okay. Hold on here. I gotta double check something. Sorry, like I said, I have a little bit of, I got Slack stuff going on at work that I have to just keep an eye on. Yes, I will make this available after live stream. So Abraham, Shalon, I will make this available. Because obviously not everybody can sit here for a couple hours and watch me do this. Some people have to work, so yeah, absolutely. Okay, oh, I don't need this anymore. Let's get rid of that. Okay. So we have our 0 case. Now we need to figure out what's going to happen with our 1 case, right? Zombies. So we're going to do it. Again, I don't really have a good name for this yet. I don't like to give things labels until I know what to label them. I have a vague idea. I know that I need to go to this 1, right? So we need to create 1. Really what I can do is just take this whole code right here and paste it in here and say, actually, if I have people, let me give it a person here. First name, what did I put? Oh yeah, okay, of course. Who would be the first name? Alan. Last name, Turing. Okay, so now that we have a person in our people array that's being passed to our person list, we should expect that when we go find our list items, there should be 1, right? If I have 1 person, I should get 1 list item. And now because I have that test in place, let's check to see if it's passing. Oh, no, it's not. Oh, look at that. 1 and 0, right? It's expecting 1, it's getting 0. Well, of course, you dummy, right? Everybody's like, yeah, of course, dummy. You don't have any list items being rendered. So what can we do in order to fix this? Well, will that work? Will that work? So look carefully at what's failing now. The one test that I just wrote, or the one test that I just wrote is now passing, but this is a different one that's failing. Expected length of 0, but found 1. So now that test that we wrote to check for 0 isn't such a bad test after all, is it? So instead of list I elements, just going straight into it, let's do this. Let's go back to a return statement. We need to have some sort of logic here. Actually, I'm not going to do return there. I'm going to do, let's do an if statement that check to see. We need to check how many people are being passed in, right? That's the condition, is that people has to be checked. So typically we would do this as, I'm going to do this as props. It's kind of the typical way that you do it is you do props. So I'm going to look on that props object and look at the people prop, and I'm going to check to see if it exists at all, because it may not be getting a people prop at all. Maybe it's not even being passed. So I'm just going to assume that that's going to happen. So if there is a people, then what I want to do is I want to return this. And if not, I'm just going to return, that just single unordered list. Will that work? Will that work? Let's take a look at our tests. We still have a problem with 0. And that's because we are somehow still getting to this if people exist. If I'm passing in people, and so it's this thing right here. Because I am passing a people, but it's an empty array, I shouldn't have any list items when I'm passing in an empty array, but that still means there's going to be a people prop. It's going to exist, it's just going to be empty. So I need a second check in here that checks not only if the people prop exists or is defined, but I also need to make sure that props.people.length is equal to 1. Okay? Again, simplest possible implementation. You may be thinking, well, wait a minute. What if you have more than one people? That's fine. We just haven't created that use case yet. There's no guarantee that that's even going to be a part of what we need to do at this stage. Okay, so I'm not going to start writing out complex code to match a use case that I don't even have a test for. I'm going to only write enough code. Remember, that second law, or actually, I'm sorry, the third law. The third law of TDD, you can only write enough production code to make a failing test pass. I do not have a use case. I do not have a test around multiple people. So therefore, I cannot write implementation code around multiple people. I can only do it for one. So I'm checking out this one person. Okay, great. Let's take a look at our tests. Oh, look, they're passing. Yay, we're passing. Okay, so is there some refactoring we can do? I believe absolutely. There is some refactoring we can do. There's a different way we could write this. There's actually several different ways we could write this component. I'll do that a little bit later. There's another refactor I want to get to a little bit later on. But for right now, what I'm going to do is I'm just going to do this. I personally prefer, I like functional programming to be written in such a way that there is only one command being executed per function. If I can find a way to refactor my code so that a function performs only one thing, I love single responsibility principle. I'm going to have one line of code that it executes. How could I do that here? How could I do that? Well, the way I can do that here is I'm going to move this unordered list up here. And then inside of the unordered list, I can put this logic. But I need to do it in a different way. An if statement could be rewritten as something called a ternary operator. So I can do that by saying these two conditions, take those out, stick them in there, and I'll drop this down so you guys can see all of it because it's taking up a lot of screen real estate. Let's move all this down just so you guys can see what I'm writing here. So I've got an unordered list that checks these two conditions, and then I can use the ternary operator to say if those two things are true, so people exist and there's a length of 1, then I want to include one of these li elements. Otherwise, undefined. Return undefined, which just basically is empty. Like, don't give me anything. Don't give me a list item. Don't give me anything. I just don't want nothing. So I could write this entire, all that if statement and functionality, I can refactor it to just this one line of code to execute. Okay? Give it a little tab Z so you can read it. Does my refactor break anything? No. Yay! So that's kind of the beauty of having these tests in place ahead of time, right? Is that we can write out our logic to be this typical complexity to reason it out. How can we make this thing work? And then the refactor phase, you're going in and saying, okay, how can I make it work better? How can I refactor this to either dry principles, solid principles, or some other set of best practices that you like? For me, personally, as much as I possibly can, I want my functions to be doing one thing. As much as possible. Obviously, it doesn't always happen. It can't always be that way. But as much as I possibly can, I want it to do that. I want it to be one line of code execution. Okay, so moving on. Obviously, our tests can't do that, right? Our tests have all sorts of different logic in it. And there is actually a way I could write every one of these tests that we wrote. I could do it in one line. I just don't want to do that to you guys. It would be a mess to try to read. It's not as, it might be good for implementing in a code base, but it's not always a hard and fast rule that you have to always stick to, especially if you want people to come back and read it later. This is probably a little bit easier for somebody to read a test than what I would do, which would be, let me just give you guys a little taste of what I'm talking about here. I could rewrite this way. Expect people, it's not going to be people list items. It's going to be off of the, okay, so the way that works is this. It's just kind of a general rule. If I have a variable, but it's only being used once, I don't need the variable. Okay, so how many times do I use this people const? Once. I use it right there. So rather than using the people variable, I can just say, okay, that's just an empty array. So that means I can get rid of this people const. Okay, next up, I have person list wrapper. Where do I use person list wrapper? Only once. So instead of having this variable person list wrapper, I could take this shallow and replace it for where my variable is, right? Okay, now I have just this people list items. How many times do I use that? I use it once. Let me get rid of that expect. I use it only once. So if that's the case, the implementation of that variable, I can just replace the variable call with the actual implementation. And now that exact same test reads like this. Would that be easy for you to read as far as the implementation? No. So typically when I'm writing my tests, I write them very verbosely, but when I'm writing my implementation, I'm writing things very, very closely, right? I have kind of the opposite. When I'm writing my tests, I want full documentation. When I'm writing my implementation, I want as skinny as I can get it, especially with JavaScript because of the way that, you know, we're transmitting these files across the internet. You need them to be as small as possible. So I try to write my code as small as I possibly can. So it's just kind of, when I'm writing my tests, I like the complexity, or I like to expand it out and be as verbose as I possibly can. But then when I'm writing my actual implementation, I like to make things as small as I possibly can. Okay, so yeah, let's that would just be a terrible. I wouldn't want anybody to have to try to read that test. That just wouldn't. Even though I know what it does, it's like, what are you, huh? To have expect shallow person list people find li to have length 0. That doesn't read at all properly. So, okay, let's bring all of this back. And let's just double check my tests to make sure everything's still passing. Yes, it is. Okay. So, yeah, that's another good one. That's another kind of good little best practice, I think, is try to make your tests, because your tests become your use cases. So if people want to know how to use your code, they'll know looking at the tests with verbosity, it becomes documentation, so you need that verbosity. But when it comes to the actual implementation of the code, I try to write it as small as I possibly can, as many one-liners as I possibly can, because it's going to shrink down how much code is transmitted across the wire. Okay, so now I need to refactor this. Going back to our, we have one person, Alan Turing. Let's give this a similar name. So renders one li element when one person exists. So there we've got our Z and we've got our O. Now we have to tackle M, multiple. What happens when there are many people? So I'm going to go ahead and copy this. We're going to say it. Again, I don't have a great name for it yet because I don't have the code written. By the way, if you guys have any questions along the way, please feel free to ask them in the live chat, and I'll be happy to tackle them. Okay, so rather than Alan Turing all by his lonesome, let's add I'm going to change some people here. I'm just going to copy this in so I don't have to type it all out. But there's going to be multiple people. We'll say Jane Curtin and Chevy Chase. People is still being passed along. There are 2 people, therefore I should have 2. Let's get rid of that extra. There we go. Okay, so now we've got our next test written. Let's take a look at it, and of course it's failing. Although that's not the reason it should fail. Let me run this again. All right, there we go. So to have length 2, so we expect a length of 2, received length of 0. How did I get 0? You may be wondering. Well, let's take a quick look at our code again. Well, we said length of 1 should display a list item, but we only have 1 list item. We've got to do something now to handle this multiple case scenario. We've got to do something to allow for this to be extended. So basically, this isn't going to work. It's close, but it's not quite going to work. What I need to do is I need to take that people, and instead of checking for a length of 1, I'm going to just do a map method on it. So it looks like this. Oops. On the map method, we can, so the map method, for those of you who are not familiar with it, it's called a transform. You take your array of people and you can create a new array of something. So I want to take this array of objects that are first and last name of people, and I want to convert it into a list item with those first and last, or I just need to create a list items. So what I'm going to do here is with the map method is what we call a higher order function, which it takes in a function. Okay, so this map method receives a function, and that function will be performed once for every element inside of the array. So I'm going to say so this function, I'm going to define an arrow syntax function, okay, of something. This arrow syntax function, the first parameter of it is the element that is currently being inspected. So understand this map method is going to call this function, this arrow syntax function that I'm passing in. It's going to call it once for every single element in people. So the first thing that it receives is that element as a parameter to the function. So I'm going to say person. Okay. So for every person, actually, I don't even need person. I don't even need that at all. I could just say, run this function. I want you to return a list item. I could do parameters, but I don't even need parameters. This is the simplest possible implementation. This is the smallest amount of code I can possibly write that's going to, it's not yet going to pass, and I think it's because, wait a minute. To have length 1. So I've got a couple of failing ones. The 1 is not passing. Why are we not passing? Person list to have length 2. Did I goof up something? Oh, I forgot the return statement, which I don't need because it's arrow syntax. That's why. Okay, I put the curly braces in there as kind of a placeholder. But if I do this, now we should be, yeah, there we go. But we have an error here. So we're passing test, but we see a console error. And that is each child in a list should have a unique key prop. So we're technically passing the test, but we are getting like a transpiling warning. So we need to fix this by adding a key to the list item element. The simplest way, I could try to do some sort of math random here, but really the simplest way is to just drop in a couple of parameters here and then take that second parameter, which is the index, and say the index. So, okay, let me go back to what the map method is doing. The map method is once again going to call this function right here, this arrow syntax function. It's going to call it once for every element inside of my people array, right? I think most JavaScript developers already know this one. But just for everybody who doesn't know, I'm just trying to explain. The first parameter of this function, which is person, is going to be that element one at a time, right? This function is being called once for every element inside of the array. Each element is going to be passed in as this first parameter. So for each person, I'm going to assign that person to this person parameter. This second variable, which not everybody knows about, React developers know about this, but not everybody knows about this. You have a second parameter for map. It is the index, 0, 1, 2, 3, 4, 5, etc. It's the index of the current element that the function is being called with. So I can receive that index as a unique value that I can then set as the key, because React requires this key, key prop. I don't know if they call it key. What was the error? Well, it's all passing now, but it requires this key to be on a list item element if you're going to have things that are being iterated. Okay, so I need this key. That key needs to be unique once for each element that's being generated. And so we can just use the I, which is the indexer of the current element in the array that's going to be unique, right? 0, 1, 2, 3, 4. Once for every single element that it's going to be different. So we just drop that in as the key, and there you go. And that's how we are able to now have all of our tests passing, because now for every instance, if I have 0, don't create any li elements, okay? Because if there's no elements in the array, there's no li's to produce. If I have 1 element, then create 1 li. If I have 2 elements, if I have 2 people, create 2 li's, etc. So we're passing. And you may be going, okay, but Steve, there's no like actual things there's just li elements. You don't have any names or anything. We'll tackle that in just a moment. We need a use case for that. All we were really saying is I need a new list item for every person. So now we have that. Okay. Next up, we need to do, okay, so we got our person list. What was my next thing here? There are multiple. Yes, refactoring. Yes, so we made it pass, but we have some refactoring we could probably do. The one refactoring that I want to do is I really don't like the fact that we're doing this check to see if people exists on props. So instead, what I'm going to do is one of the cool things that you can do is you can set a default value for a parameter. So up here in my props, I can set a default value for people, but I need to, what I want to do is I want to, instead of getting all of the props, I'm going to destructure the people out of props. So the way you do that is you just simply wrap up in curly braces, and then you name the property on here, people. Now this is exactly the same thing we're doing up here for shallow out of Enzyme. We are destructuring the shallow property from the Enzyme library, or the Enzyme class, or the Enzyme module, whatever it is that's back there. We are destructuring shallow from out of Enzyme so that we can have it. This is exactly the same thing we are doing right here. We are destructuring the people property from the props. We're passing in props, but we can take a particular property on those props and say, I just want to define that people as something, okay? As something that I can use in my code. That's exactly the same thing we did there. So whenever you see this syntax, just know that's what's going on. You are destructuring, we call it destructuring in JavaScript. You're taking that one element, that one thing, that one property, and you are bringing it in as this thing, right? And you that way you don't have to bring in the whole thing. You don't have to bring in all of it. You don't have to bring in the whole library. You just bring in that one piece of the library. Okay? It's the same thing here. Instead of bringing in the whole props, I'm just going to bring in that one little piece called people. Now that means that I don't need props anymore. I can drop that, and I can drop that. But the other cool thing that we can do is we can set a default value for people. So right now, we've been checking to see if people exist because it's always been possible that there's no array being passed at all. What if person list is being called, but no people prop is being set at all? That's why we have this, okay? So but what we can do is, in our parameters, we can set a default empty array so that if there are no people being passed, if nothing is being passed for the people prop, set it to an empty array. And if it's an empty array, we don't need to do this check anymore. Now we can just simply say, iterate over or map over my people array. It's either going to be empty or it's going to be full. Either way, it's going to still generate the LIs. And if we take a look at our test suite, everything passes. Cool, right? So these are the kind of cool refactors that you can do because I have tests in place. If I didn't have these tests already in place, how would I know this is working? How would I know that my refactor that I just did, how would I know that didn't break something? But because I've done all of my tests ahead of time, I know that nothing is broken because of this refactor. Okay, all my test cases. The test cases of where I have nothing being passed to the person test component, where there's no props at all, that's being tested. I have the one where there is something being passed, but an empty array, that's being tested. I have one where there's one person being passed in for that props, that's being tested. And I also have the many now, right? I have 2 or more people, and that's allowing me to do this map method. So that's how essentially the testing has driven out the development, the design of this thing, okay? We're approaching 2 hours, so I'm not gonna continue much further. I just want to get to the point where we're starting to actually list the names. So so now that I have these list elements, one for each person that gets passed in, now what I need to do is make sure that the people are actually getting displayed in the list item elements. So I'm going to write a new test here. Oh, actually, before I do that, I need to do this. So it renders one li element for each person that exists. Okay. That refactor shouldn't have done anything. Yeah, I mean, we're still green all across the board. Okay. It. All right, we know that we want it to display people names. So I'm going to add I'm going to add a test that's going to check. So let's go ahead and do this kind of thing again. And so I'm going to do just one person here to do this test. I'm going to say when I pass in one person, that's fine. We'll stick with Jane. What I want to do is now take a look inside of those li elements and make sure, which there should only be one, right? Because we're only passing in one person. And I want to check to see that the names are appearing inside of the list item elements. By the way, let's just double check, make sure all my tests are still passing. Yes, they are. Okay, so none of my tests that I've written so far have broken anything. So I need to expect that the list item elements, you know what? Let me go get those that list item element, person list item. We're going to say is off of person list wrapper. And we're going to find, of course, the li elements. And let's do, so I want to expect that the person list items, let's go for 0 dot text. So I'm looking at the text of that item, and I know that I want it to have to contain that person's name. So we're going to do people 0 first name. Okay, so that's essentially what we're looking for. We're looking for the text to be first name. And in fact, why don't I go ahead and throw on an expectation? And this is sacrilege in some people's circles, and I kind of hate doing this, but having multiple assertions inside of one test is kind of a no-no. There's different schools of thought on this. I prefer, again, adhering to single responsibility principle, I prefer one assertion per test. However, I fully admit that sometimes it can be overkill. And in this case, we're really just checking to see if the name, the first and last name, is being displayed. So I can understand why somebody would argue that it's perfectly acceptable to have an assertion of two things because we're really checking for both things to be true for this one test. Okay. My personal preference would be to actually move this into two separate tests. But that's just kind of my draw, but I'm perfectly fine having multiple assertions if it makes sense to do so. Because this is really still, this could be argued that this is still the same thing that we're testing. That it is still adhering to the single responsibility. Because first and last name are really kind of, we're just testing the name in general. Okay. Better label that last name. So we're looking for both of these two things. And of course, if we take a look at our tests, it's not passing. Read property text of undefined. What did I goof up there? What did I goof up here? Let me do this. I think I need to do it this way. There's only going to be one element. I think there's only going to be one. So it's going to do that. That's the way I originally wrote it. I'm not sure why. I'd have to go back and double check exactly why that code's not working. But essentially, this should work. Yeah, that should work. So now my test fails because to contain. Yeah, that's where it should be failing. Is it to contain? It's expecting substring Jane, or yeah, substring of Jane, but it's receiving empty. So let's figure out what's going on there. How can we solve this? Well, the simplest solution is the one that we want. We can go into person list, and all we have to do is, well, we're already getting the person from inside of the, from each of the people array. We're already getting a person one at a time. So we can, inside of our list item element, just simply add person dot first name and person dot last name. And of course, if we go check our tests now, everything passes. Okay, so we're allowing again, the tests themselves to drive the design, right? Is there any sort of refactoring? Yes, I want to probably say something like, it renders the first and last name of a person. There we go. So that's probably all we should do. I have more to this, like adding edit buttons and adding an edit screen component. But I think you guys can see we've worked through a pretty sufficient example as much as we possibly can. And now it's time to kind of turn over to another component and adding edit buttons. But we've really driven out the design of this application using tests. So just to kind of wrap this up and put it in a conclusion box, I want to go back to the slides, because the three practices that we need to be remembering to implement here. First and foremost is the obvious one of TDD, where you first write a failing test. Then you write just enough code to make the test pass, and then you go back and you refactor. And during the refactor phase, this is where you're looking at things like solid principles or dry principles, and you want to do that with your tests too, right? We saw early on I was willing to delete tests that were no longer relevant, right? If it's a test that's no longer applicable, delete it. Don't let it just sit there and rot. But be careful though. Be careful that you know which tests you want to that are actually not testing anything. Those tests that are not testing anything, you should definitely get rid of. But in general, you want to keep as many of those tests that make sense to keep, right? And don't just, if it's covering one of those zombie cases, n zombie cases, null, 0, 1, or many, obviously you want to try to keep those test cases around. You let the tests drive the way that you do things. And when you're doing the test, that's when you're thinking about what you need to do next, right? When you're thinking about what is the next test I need to write. That's the whiteboard. That's the design part of things. That's when you're thinking about things through. Okay, that's why they call it a whiteboard. Is when you're designing the test, you're really thinking about how do I want to shape this application. You don't do it in the implementation code, you do it during the test time. And I hope that you guys can see while we were going through this exercise that that's really kind of what we were doing, is we were figuring out what the next thing to do was based upon, okay, what do we want the system to do now? What is the next thing that we want it to be able to do? And so hopefully you got a little bit of that. Obviously I have a little cheat sheet with me, so I was kind of looking at that going, okay, what do we need to do next? But I think that you guys can see that there's a flow that you go through. And NZombies is a good way of doing that. So anyway, going back to TDD, we got this red-green refactor cycle that we're constantly doing. We do it over and over again. It should only take, I'm sitting here explaining everything as I'm going along, so obviously it takes me a little bit longer to do each one of these cycles. But in practice, this should probably only take you maybe 30 seconds, unless it's a really complex problem. But yeah, basically it should only, you do it in these small little iterations like this, it's only going to take you 15, 30 seconds each time. So it seems like a lot. One of the, before I end this stream though, there is one thing that I really wanted to say during this stream. Aside from thank you everybody for watching, I really appreciate it. And I hope you guys enjoyed it. There was a classical argument that goes on about whether or not TDD is a good practice. And you'll find there's a lot of detractors, and that's fine. What I typically go through is I say, okay, first and foremost, can we agree on this? We want our applications to work. Okay, if you and I can agree that we want our applications to work, great. Now let's go to the next thing. What is the best way to ensure that the system is working? Is that through manual testing or is that through automated testing? I think the likely and most responsible answer, most intellectually honest answer is automated testing. We need some sort of automated testing. That's why that's why we have a QA department pretty much in general. Like that's why QA exists is because we do a lot of this manual testing instead when we should be doing automated testing, and we prefer automated testing. And sometimes the QA role turns into how can we write more tests? How can we do better testing? That's really what QA should be about, is how can we do better testing, keeping track of bugs that are coming in, and then figuring out what type of tests need to be written around those bugs. That's what QA should be doing. Oftentimes what they're relegated to do is make sure that if I click on a button, it runs, which there's automated testing frameworks around that. So we should be doing the automated testing. So I think we all agree, I think we should all agree, I don't think it's very difficult to make the logical conclusion that the best way to ensure that a system is up and working is by having an automated test suite. Okay, now the third thing is, once you and I can agree that the application should be working and that the best way to ensure that is that we have automated testing around it, then my only question is, when do you write those tests? That's the only thing in question here, is when do you write the tests? Before or after you write the code? Before or after the implementation? So in my opinion, I'm a better developer and I have a more complete suite of tests if I do my tests first. Because I know there isn't a single line of code in my production code that hasn't been fully tested before I even wrote it. There's not a single line of the code that we wrote today that isn't fully tested. There's some stuff that comes out of the box that presumably somebody else already has tested, but every line of code that we wrote today was tested, except for the tests themselves, I guess you could say. But even those tests were essentially tested by whoever created the frameworks, right? So, I mean, there's nothing that I wrote in production that wasn't fully tested before it was even written. I let the tests drive out the design and the code. So tell me, would you like that level of security and comfort in the code that you write, that there is always a test backing up every line of code? Or would you rather write your tests afterwards and hope and pray that you completed all of the tests that were necessary? And not only that, but I think that this is a much more fun and enjoyable way of writing tests. Because I don't know about you, but when I go and I write tests after the production code, it feels like, man, I already know this works. Why am I writing tests? So we tend to get really lazy while we're writing those tests, right? We tend to kind of go, it already works. I don't really need to do a complete testing. I don't really need to completely test this system. It's already working. Okay, well, that type of attitude and behavior is exactly what causes brittle code. And so to me, it's an obvious practice to take on. Because if you write your tests, we already know, first of all, we know that we want a working application. We know that the best way to do that is by writing these automated tests. And now we know that if we write the tests ahead of time, we have a much less of a likelihood that we're going to miss a test, right? It's almost zero. Like the percentage of chance of me forgetting to write a proper test is pretty much nothing, because I have to write a test first before I write the application code. So in my opinion, there is no reason why you shouldn't be doing TDD. There just isn't. Unless you essentially, and what it kind of breaks down to, and I hate to be blunt about this, but unless you don't really care about the quality of your code. If you don't care about the quality of your code, then fine, do whatever. You don't have to do TDD. I do it because I believe that this is the best way. And if you've got a better way, by all means, I'm willing to hear it. This is the best way that we have been able to come up with. Us as a body of people. I mean, there's people all over the place that they're coming up with different ways to do things. And you're telling me that after all this time, somebody hasn't come up with a better way than this. So this is what I think we should be doing in order to have the best code that we could possibly write. And ensuring that the system works. Right? So that's something I just want to talk about in TDD in general. The other two things are the 3 laws of TDD. Again, this just kind of, these laws really help you narrow your focus of what you're writing and really kind of add some constraints around how you write your code, right? So TDD is the practice.